In the previous video, we have seen an overview of n-queens problem. In this video, we will see how to solve n-queens problem using JavaScript. So I'll write a function n-queens. This will receive an argument n, that is the number of queens to place. So what we will do is we will have a two-dimensional array. We will initialize all it to 0. So wherever we want to place the queen, we will update it by 1. So let me create a two-dimensional array. I can use array.from to create the array of length n, and I will map this array to create inner arrays. So I'll return again array.from of length n, and I'll fill everything with 0. So we can print this board and see if we have initialized it properly. So I'll write a function called print board, which will receive board as the parameter. And what I will do is I'll loop using for of loop row of board, and I'll console log json.stringify of row. So let me call this function of board, and I will print empty board here, and I'll finally call nqueens of 4. So as you can see, this is the empty board with all zeros. So wherever we want to place the queen, we will update it to 1. So we will have two functions. One is can place queen function. This will determine whether I can place the queen in a cell. This will receive the board and row and column as parameters. Currently I'll return false. We will define this function later. And the next function is place queen. This will receive the board and the column. So this will return false for the time being, and I will call if I can place queen in the board and the initial column is 0, I will log solution and print board of board. Else I'll print there is no solution. So this is the skeleton of our code. Now let us implement both the functions. First I'll implement the place queen. We will be calling place queen in recursion. So let us define our base case first. So if the column crosses the board length, that means we have iterated throughout the board and we have reached the solution, so we will return true. Now what we have to do is we have to try placing queens one by one. So let us iterate I, which will represent the row, until board length. Board length is nothing but the n, the number of queens to place, and we check if I can place the queen in the ith row. So I call this function can place of board comma I comma column. So if I can place the queen here, I update that board cell, that is I comma column is equal to 1. Now I have placed the first queen in the first column. Next what I have to see is whether I can place remaining queens in the remaining columns. For that, let us call place queen. If I can place queen in board comma next column, that is column plus 1, then I return true. Otherwise, I need to go back and update this 1, whatever I updated to 1 to 0. So I need to reverse this operation and I'll make it as 0. So this is the backtracking step, and we go back and try to place it in the next column and see. So to revise, first we check if we have placed all the queens, then we return true. Then for each column, we go row by row and try to place the queen. So first we place the queen here. Here can place will be true, and we give it 1 here. Then we check if we can place the queen somewhere in the next column. Again the same function will be called. I'll end up placing the queen here. Then again same recursion will happen. I'll try to place a queen here. I'll not be able to place the queen anywhere here because other queens will threaten it. So the return of this call will be false. So I'll come here and update it to 0. So this cell, whatever I have updated to 1, will become 0, and I try to place queen in the next column, and this process will continue until all the conditions are satisfied and we get a solution. So now we have to implement can place queen function. So we will have three checks here. One is check if queen exists in the same row to the left of current column, which means let us say we have a queen 1. While trying to place another queen here, right, we need to check if there is a queen to the left of it. We need not check to the right of this because we are traversing from left to right. That is the first case. The next is check if queen exists in the diagonal to the top left. That means while trying to place a queen here, I need to check if there are any queens to the top left diagonal. No need to check to the right side since we are traversing from left to right. And the third thing to check is check if the queen exists in the diagonal to the bottom left. That is, let us say we have placed a queen here. If you are trying to place a queen here, we need to check to the bottom left as well. So let us implement one by one. So I need to loop row by row until column, that is for I is equal to 0 to column if board of row comma I. That means in the same row if there are any other queens exist in the previous columns. Then return false. I cannot place the queen here. So how do we check diagonally left to the top? If you're considering this, then we need to decrement both row and column simultaneously to get the top left diagonal item. So for I, we will start I from row and j from column. We need to go until the start of the board, that is I greater than or equal to 0 and then j greater than or equal to 0. To top left we need to decrement both I and j. Now we check if board of I comma j is 1, that is queen is already present in the diagonal, then we return false. And the last case is similar to the previous one. I'll just copy this and update it. Here we are going top left. Instead of going top left, we need to go bottom left. So we have to go for I until board dot length, and we need to increment I since we will be going to the bottom. Finally, we need to return true since all the condition has been met. So as you can see here, we got a solution. So we can compare this with the one we have got in our slide. So as you can see, it is queen here, yes, one here and one here and one here. So that is matching a solution. We can check for placing 5 queens. We are able to place it. If we check for 3 and 2, there is no solution for that. So this is how we can solve n queens problem. And coming to complexity, this algorithm has a complexity of big O of n factorial because we are calling place queen in recursion and each time the n size reduces by 1. That's all about other algorithms. In the next video, we will see different algorithm design techniques. Thank you for watching. Hope you liked the video. If you did, please consider subscribing to the channel. See you in the next one.